This is the initial description of the compositor effects. It was a suggestion from Retas, and this adds the ability to register rendering effects as callbacks in the rendering engine. Here are some examples like this rain reflection effect using a mask from the debuffer. As you can see, there are some areas that show neither reflection nor rainfall. The mask is extracted from a camera using compositor effects. It's very cool. This is another example of distortion using the velocity map apparently. It's very interesting. As you can see, when the object moves, its shape is distorted, as well as the colors and the light it emits. Also this other one, which is a data mesh effect. And finally my version, which simply does a pixelated effect on the color buffer using the velocity map. As you can see, the image is distorted when you move the objects on the screen, so also with the movement of the torus here. Now let's review the simplest effect that comes in the Godot examples, that is grayscale. For that, I go to the World Environment node and select the Compositor field. First, I'm going to delete the effect that is loaded, and I am going to clean up, and then I'm going to add a new compositor and add a new element. This is going to be the grayscale effect. And now we're going to see its structure, as it is very simple. It consists of two files, that is the file that defines the effect in GDScript and the file that contains the compute shader. First, we see that compositor effect inherits from the source, and we have to declare a class name that will appear in the compositor field, in the world environment node, or in the camera node. Now, we start the compute shader, and here we choose the rendering phase. It can be any of these listed here. So I'm going to write a comment, station the rendering pipeline. This line free resources that we will create later. And these are some variables for the compute shader. And this file is the shader sphere. That is a low-level representation of the shader. And it can be compiled into binary shaders. Now, the most interesting part is the render callback. Here we're going to run this code if it's the correct rendering phase that we defined before. These are the different buffers. And next we get the size from them. And here we specify how to process the data in the compute shader. And this line doesn't work anymore. Now these are the buffers where I'm going to extract the color buffer. You can extract the map and the velocity map, for example. And here is the uniform that I am going to use to pass the color buffer to the compute shader. Here are the lines to execute the compute shader. They specify the pipeline, uniforms, and how to run it. Godot doesn't allow me to modify the GLCL file, so I have to use another editor like VS Code. First, I write the specific lines for Godot in the compute shader. Next, the invocation lines that corresponds to these lines in GDScript. And then I specify the uniform that I'm going to call color image. It's going to handle the color buffer. Now, I create the UV coordinates, and then I sample the color buffer in this variable. Then I convert to grayscale values, and then I write to the buffer. Now I can see the result in the viewport. Now I will explain the pixelization effect, which is quite simple. I will do it directly from VS Code, and the GDScript file is almost the same. The only difference is that I get the velocity buffer from the scene buffers, and I create a second uniform to pass the velocity buffer to the compute shader. Now, the compute shader is almost the same. The difference here is that I will create a grid that represents the pixelation effect. Then I'm going to take a sample of the color buffer and another sample of the color buffer, but in the grid that represents the modified coordinates. Now, I want to show you what the velocity buffer looks like, so I'm going to replace the color buffer with the velocity buffer. But I got an error, and it's just a bracket, so I'm going to fix it. And I'm going to reload the compositor effect, and you can see the velocity buffer, but it has negative values in one side of the movement. So I'm going to take the absolute value. Now, by making this adjustment, I can see the velocity vectors on both sides of the movement. The velocity buffer works with respect to the screen space, so I reload the compositor effect, and you can see the effect on both sides of the movement. Now I'm going to rename this variable, and I am also going to separate the mask that I defined for the effect, which is just the length of the absolute value of the velocity vector. Now I want to display the mask on the screen, so I have to replace the color buffer with this variable. So I'm going to reload the compositor effect, and now you can see the mask that I am using, but I realize that it's negative, so I'm just going to invert it in the compute shader. After doing that, you can see that it now displays correctly for my purpose, which is to mask the effect. Now I have to invert the values in the mix functions as well. And finally, I can display the effect using the res variable. I reload the compositor effect, and you can see the final result. And that's it.